next up, we have Maeve in neuroscience, which is pretty exciting. And right after that, we've got Luke and Deanna. Deanna, who's somewhere here, I think. Oh, there you go. Perfect. All right, let's give it up for Maeve.
Okay, today I'm going to take you through a modified version of my senior thesis. I know this looks like a lot, but stay with me. Okay, number one, my partners and I were interested in understanding addiction. There are 3 stages of addiction in the literature, but we focused on reinstatement or relapse. This is the least studied of the 3 stages, so obviously we focused on it. There are 3 regions in a rat brain that are associated with relapse. I labeled them A, B, and C for simplicity purposes. Our goal was to edit the connections between A, B, and C in order to prevent relapse from happening. We did so using something called a chemical virus. This was not like the flu and did not harm the animals. By injecting this virus and blocking these regions, our goal was to prevent reinstatement in these rats. So our hypothesis was by blocking both of the pathways from A to B and A to C, we would be able to prevent reinstatement. Okay, number 5 is the trickiest part, but I'm going to get you guys through it. Before getting to relapse, we did establish an association between the drug and the animal. We did so using something called CPP chambers. Rats chose their naturally preferred side during a baseline test. Let's say this rat chose black. Rats were then given amphetamine in their non-preferred side, so this would be the white side. After 8 days of continuous amphetamine injections, rats were given another test. If they then preferred this white side, or their non-preferred side, they would be considered addicted to the drug. They could then undergo extinction, in which we took away the drug for 8 days. Another test was done to determine that the rats no longer had a preference for this drug side. Then they could move on to our final stage, in which we gave them the drug again and injected something that would activate the virus that we originally intended to block the pathways. So to reiterate, we originally hypothesized that the pathways in blocking A to B and A to C would prevent relapse. So we did actually find that. Number 6 shows a graph made by one of my thesis partners. On the y-axis is the amount of times each rat spent on the drug-preferred side. So in the previous example, it would be the white side. And on the x-axis, we have the baseline test, the test saying that they prefer to spend more time on the drug side. We have the extinction test, and then finally the reinstatement test. So basically, what we found is that by blocking both pathways and the pathway from A to B, we would be able to block reinstatement in rats, which is pretty cool. This is obviously, our study has limitations, but it's a great addition to the literature on the neurobiology of addiction. Thank you.